A shopper pushes a 12-kilogram grocery cart with a constant force F, oriented in a direction 25 degrees below the horizontal. The cart moves a distance of 20 meters at constant speed on level ground. The friction force between the wheels of the cart and the ground is 35 newtons. In the first part of the problem, we need to draw a free body diagram and find the applied force F. Let's start by identifying all the forces acting on the cart. I will consider that the x-axis is oriented horizontally positive to the right, and the y-axis is oriented vertically up with a positive direction. The force applied on the cart, F, has a direction that is 25 degrees below the horizontal. Therefore, the force F will make an angle of 25 degrees, denoted here with the letter theta, with a horizontal direction. This is the first force that we can easily identify as acting on the cart. Next force is the force of gravity. Remember, force of gravity acts on all objects on Earth. Force of gravity is always oriented vertically down. Because the cart is in contact with the ground, there is a normal force that the ground applies to the cart, oriented perpendicular to the ground, vertically up. And last, we have the friction force between the wheels of the cart and the ground, which is oriented in the opposite direction to the motion. Now, let's build a free body diagram by identifying the x and y coordinate system and translating all these forces to the coordinate system such that their origin is in the origin of the coordinate system. The force F will make an angle theta with the x-axis. The force of gravity will be oriented vertically down along the y-axis. The normal force will be oriented vertically up along the y-axis, and the force of friction will be oriented horizontally to the left along the negative x-axis. Don't forget that the cart is moving to the right, so you want to indicate that on the free body diagram. Now, in order to find the applied force, we need to use Newton's second law. Newton's second law states that the sum of all forces acting on the cart equals the mass times the acceleration of the cart. Because the cart is moving at a constant speed, it means that the acceleration of the cart is 0, so the sum of all forces will be equal to 0. From this equation, we need to find the force F. As you can see from the free body diagram, every force has a different direction, which means we will need to find the x components and the y components of each force and add them separately. Let's start by finding the x component of each one of these forces. I would like to remind you that the x component of a vector can be calculated as the magnitude of the vector multiplied by cosine of the angle made by that vector with a positive x-axis. So, for example, we start with force F. This force F makes an angle theta with the x-axis. This angle theta, though, is measured from the positive x-axis clockwise. What we need to identify is the angle made by the force F made with a positive x-axis and measured counterclockwise. And that would be an angle of 360 degrees minus the angle theta. Therefore, the x component of force F can be written as the magnitude of F multiplied by cosine of 360 minus theta, which is nothing else than cosine theta. So the x component of the force F is F cosine theta. And now we go to the next force in the sum, the force of gravity. In this case, the force of gravity makes an angle of 90 plus 90 plus 90 with a positive x-axis measured counterclockwise, which is an angle of 270 degrees. Therefore, we can write that the x component of the force of gravity is equal to the magnitude of the force of gravity, which is calculated as mass times gravitational acceleration, multiplied by cosine of 270. Next force is the normal force. The normal force makes an angle of 90 degrees from the positive x-axis. Therefore, the x component of the normal force is equal to the magnitude of the normal force multiplied by cosine of 90 degrees. And the last force that we have to find the x component for is the force of friction. Force of friction makes an angle of 180 degrees with a positive x-axis. Once again, the angle has to be measured counterclockwise. So we will write the x component of the force of friction as magnitude of force of friction multiplied by cosine of 180 degrees. The sum of all the components along the x-axis equals 0. Now, don't forget that cosine to 70 degrees is 0, so this goes away. Cosine of 90 degrees is also 0, and it goes away. And we are left with f cosine theta plus, we have the value of the force of friction as being 35 newtons. And we know that cosine of 180 is minus 1. So the equation will be as shown here. Force F multiplied by cosine angle theta is 25 degrees as given in the problem, plus magnitude of the force of friction is 35 multiplied by cosine of 180 is minus 1 equals 0. From this equation, we obtain that the magnitude of the force F is 38.62 newtons. Now, in part B of the problem, we need to find the work done on the cart by each force. Let's write down what the problem gives us. We know that the mass of the cart is 12 kilograms. The distance the cart travels is 20 meters. The angle made by the force F with a horizontal is 25 degrees. The force of friction is 35 newtons, and in part A of the problem we found that the force F applied to the cart is 38.62 newtons. We need to find the work done on the cart by each one of those four forces. Well, all forces are constant, therefore we can calculate the work done as the magnitude of the force multiplied by the displacement of the cart under the action of that force multiplied by cosine of the angle between the force and the displacement. So let's start by calculating the work done by the force of gravity. According to the definition of work, work done by the force of gravity will be equal to the magnitude of the force of gravity, which is mass times gravitational acceleration g, multiplied by the distance traveled by the cart, which is distance d of 20 meters, multiplied by the cosine of the angle between the force of gravity and the displacement. In this case, the cart moves to the right along the horizontal axis, and the force is oriented along the vertical axis. Therefore, the angle between them is 90 degrees. The work done by the force of gravity will be equal to the mass of the cart is 12 kilograms. The gravitational acceleration g is 9.8 meters per second squared. The distance traveled d is 20 meters, and cosine of 90 degrees is 0. Therefore, the work done by the force of gravity is 0 joules. When the force is perpendicular to the direction of motion, that force does no work. So this is the work done by the force of gravity. Next, let's find the work done by the normal force. Once again, we use the definition of work. The work done by the normal force will be equal to the magnitude of the force normal multiplied by the displacement multiplied by the cosine of the angle between the force and the displacement. The normal force in this case is perpendicular to the displacement. So the work done by the normal will be normal force multiplied by the distance d multiplied by cosine 90. Because cosine 90 has a value of 0, normal force is perpendicular to the direction of motion, the work done by the normal force is 0 too. Next, let's find the work done by the force of friction. In this case, the force of friction is along the direction of motion. While the cart moves to the right, the force of friction is oriented to the left. Therefore, the angle between the force of friction and the direction of motion is 180 degrees. So the work done by the force of friction will be equal to the magnitude of the force of friction multiplied by the distance traveled multiplied by cosine of 180 degrees. The magnitude of the friction force is 35 newtons. The distance traveled is 20 meters. And cosine of 180 degrees is minus 1. Therefore, the work done by the force of friction is minus 700 joules. Force of friction does negative work because it is oriented in the opposite direction than the direction of motion of the object. And the last force is the force F. So let's calculate the work done by this one. In this case, we can write that the work done by the force F will be equal to the force F multiplied by the displacement or the distance traveled d multiplied by the cosine of the angle between them. The angle between the direction of motion to the right along the x-axis and the force F is nothing else than the angle theta. The work done by the force F will be equal in this case to 38.62 newtons, the magnitude of force F, multiplied by the distance traveled, 20 meters, multiplied by cosine of 25 degrees, because theta has a value of 25 degrees. In this case, we get a value of 700 joules for the work done by the force F. In the last part of the problem, we need to find the total work done on the cart. The total work represents the sum of the work done by every single force. So we know that the work done by the force of gravity is 0, the work done by normal is 0, the work done by the force of friction is minus 700 joules, and the work done by the force F is 700 joules. Therefore, the net work will be the sum of these individual works. And if you look at the values, you realize that the net work is 0. Does this make sense? Well, another way to calculate net work is by writing that net work equals, from the definition of work, the net force multiplied by the displacement of the object under the action of net force multiplied by cosine of the angle between the net force and the displacement. In this case, the net force, as we saw in part A of the problem when we use Newton's second law, represents the sum of all forces, and because the cart is moving with a constant speed, it is equal to 0. Since the net force is 0, it means that the net work will also be 0.